Welcome to a new test and teardown video. This time it's another Bang & Olufsen Wow and Flutter meter WM2. I think this one is from about 1986. At least that is what is written in the manual I was able to find at peel.dk. He collects manuals for all sorts of instruments, and he's especially happy about Danish instruments. And this one is in a very sad condition, especially when we look at its outer casing. Look at the rust. It's not so bad here on the side, but yeah, I have to open this one and inspect it much deeper before I power this up. I mean, was this placed outside in a barn in the rain? I don't know. We also got a little bit here at the front where rust is coming through the paint. Oh yeah, and also here. If you don't know about Wow and Flutter meters, they're mainly from the good old days with tape recorders and stuff that is moving. And the whole idea is there is a generator here with 3.15 kilohertz, and the idea is you record this and then play it back through this instrument. And then it analyzes the drift and the wow and the flutter. So what is the difference between these three things? That is the frequency of the variations. So drift is like a constant offset. Let's imagine the tape recorder is running a little bit too slow when it's recording and a little bit too fast when it's in playback mode. That means the output frequency is different from the recorded frequency, and that is your drift. Drift can be from constant and up to about a half a hertz or something like that. Very slow drifting, like an offset or an error, constant error. The wow is a frequency variation between a half a hertz to 6 hertz, and the flutter is of course the same thing but just faster, from 6 hertz to 100 hertz. And that is why you have these different filters of variations where you can say wow or flutter or wow and flutter or linear mode, and then you can see how much you got. You can also say how much of drift you got, and then you, as far as I understand, you can tune to the exact drift, and then the wow and flutter system will work. It's probably not working if you have a drift not correctly tuned in. So that is more or less how this should work. On the back we find a few connectors, so the output can go through some external filters in case you want different filter responses. You have the output for drift. See, it's a DC, and then you have wow and flutter in either AC or DC components. There's a service lid here at the back that is also screwed to the chassis with a screw in the middle, and the circuit board is really beautiful. Again, this is before CAD, so everything here is done by tape and transparent film. I really enjoy looking at layouts like that. Look at that ground traces. I mean, let me try and point to that detail here. Look at that one. So this is a ground point or some special important stuff. and then it splits up so they don't affect each other. I mean, I just really love design details like that. And they really did pay attention to details, because this is a very, very sensitive instrument. Yeah, absolutely beautiful. I'm a little bit sad about the corrosion that we have here around these, but of course it has been standing on some wet shelf where it's been raining or something like that. Probably a wooden shelf somewhere, right? And you can imagine all this moisture just go here and transport itself via the rubber feet and then to the metal here. And that's why it's nice and fine here, because it wasn't touching the wet wood. And it's the same on all the 4 feet. That is where we have a higher concentration of rust. But luckily the internal parts all nice and fine. I want to show you a fun detail about the chassis assembly. If you look at the screws here, you're not supposed to unscrew them completely, but just loosen them. So the idea is this piece of metal here can move a little bit. And here at the rear, this one gets loose, and see those long screws reveal. You're not supposed to unscrew them completely like I did, because I didn't know this detail. So that is why I'm sharing this. The idea is, here is the lid, the insert side of the lid, where we have the grooves for the screws. And you can imagine this one sticks in here. And when you tighten the screw, you just squeeze to this piece here, and this holds the entire chassis frame together with this one. I mean, it's just quite funny. And this is the top side of the circuit board. It is just nice and fine for a single layer design. Really amazing. They've done a good job here. And as you can imagine, mains, transformer, rectifier, capacitors and power supply kept in the far corner, and then inputs, outputs, connectors in the other corner, so the distance between those 2 parts most possible. And that is a good way to think. And these guys, they know how to deal with stuff like that. And this is a capacitor type that is famous for leaking or cracking, but I've been inspecting them and see, no problem so far. But I would definitely recommend to replace them every time you see this type of capacitor. Look at that, a thin film. Well, it's not really a thin film, it's just a thin piece of normal circuit board. And it's simply made so they don't have to poke around with all those cables and do them wrong and connect them wrong and whatnot. I mean, just solder and put in the connector, and everything is always the same all the time. Very good design. And this is designed for easy manufacturing, cheaper and faster, smarter and less errors. Oh yeah, there's another really cool thing in this unit. Of course, this is all about making frequencies, but also comparing a frequency to some filters. And here is a crystal oscillator. And all this here is, of course, generating the exact frequency we need, the 3.15 kilohertz. So we've got some amplifiers and op amps and all that kind of stuff down here. And here is this is a counter, the 4040, that will divide the crystal frequency down, maybe we can see what is the frequency here. I don't know, understand exactly that. Yada yada rubbish, but it's definitely that way it works. Okay, here we go. So it's 6451.2 or some stuff. Yeah. Well, quite a lot of trimmers and adjustments. I hope I don't have to poke around too much with any of that. Yeah, let's see if there's any kind of output or anything going on in here. So let's try the first power on. Let's see if there's any kind of stuff that is going on. We got an output. Yay, that is good. And it is changing the frequency. I don't know if this is easy to see, but let's go a little bit closer here. So what you need to look at is this number right there. So if I dial the potentiometer, no. If I move that, no, this has nothing to do with that. It's only a meter thing. Okay, so there you have it, 315. It is a little bit distorted, I would say, but that is not super important because this is not a harmonic analyzer or anything like that. So here you have the frequency output is working. So now I want to try and put that in, and then we'll see what happens. At the moment it says no input, so that is also a very, very good sign. And I can of course take its own output and put it into its own input. Fine. Oh, even that one seems to be working a tiny little bit. So here is the deal again. We got no output now because I got input. Look at that lamp here. If I turn off my signal generator, no input, and then it outputs something. You see that on the scope. This is so you can record something with the built-in signal source. So I'm using an external oscillator that's generating 3.15. So every time I turn this on, of course it turns off its internal source, so everything here is more silent, so there's no beating with this internal oscillator and all that kind of stuff. So I have now a WoW and a Flutter enabled, everything, and then you see the entire frequency range here on this little picture. See, if I look at only the lowest of WoW is all this to this, and then you go Flutter. Flutter is a higher component all the way up, and this is both. And then it has some other, I don't know, I don't understand exactly what this is doing. So this is only, this is the center point here. That is interesting. Anyway, so there's a nice graphical readout. So I'll focus on this one, right? And there you have it. My drift is in the 0. So let's try something funny. So this is my input is 3.15. What if I have it, of course, now in 10%. So this is the drift. 3.1, 3.2. Look at that. So again, since there is no change, then the flutter meter goes down here. Or the wow flutter, whatever. So this goes down. But now I have, of course, a drift. And then I can go back to 0 with that one. So that seems to be working. What if I take 3.15 and then I go one more digit down? So I should go all the way down here. Then it goes critical, right? So this is 1% for full range, and now I am at, yeah, see, check. So this is the 4th digit. Now it's 3.155. And every time I change to something, see, there's a change. How cool is that? The faster I change it, the more we read. So I really think it really works. Interesting. I can, of course, add a little bit of FM modulation to my 3.15 using my signal generator. So this is what I'm doing here. So we got 5 hertz of FM frequency, and we got 5 hertz of frequency deviation. So, and that is why you see this. You can actually see that it's moving a little bit. And I can trim this back to 0. But everything is a little bit nervous right now, and it is going. But here's the flutter. So if I change the frequency deviation, that is 5, 4, 3, 2. So this is how much it is deviating. And if I go up to the frequency of modulation, so if I change the frequency there to 4, 3, then you see it goes slower. And I'm still in the frequency range of this peak. See, this is 1 hertz to 3 hertz is where this peak is. So if I move the frequency up, so this is 10 hertz, 20. So, okay, let's go to 20. You're probably going to see much less. See, now it is much less. So let's see if we can figure out how to get, see? And now we change the frequency range here. So this is in 20, see, now it's in there. Well, and this is the linear. This is everything. Well, I definitely think it works. So, all we need now is a tape recorder. Well, I don't have any, yeah, maybe I have actually. But that was not the scope of this video. I just wanted to show you guys a really funny old instrument from the good old tape recorder days. So thank you very much for watching. I hope to see you soon again. Bye.